Hi guys, welcome to this video on dividing complex numbers. So, dividing complex numbers, we're going to learn to divide a complex number by another complex number. We're learning this because operations on complex numbers are an important ACT skill, and you know you're successful when you can divide two complex numbers like 5 plus 3i divided by 2 minus 2i. So, there's a couple things that you got to know. Two pieces of important prerequisite knowledge for dividing complex numbers. The first is that you got to know complex conjugates. So if you have a plus bi, its conjugate is a minus bi. And if you have a minus bi, then its conjugate is a plus bi. It is very important to know these things. In the situation where you have bi by itself, so it doesn't have a real component, then its conjugate is just the negative version or the positive version, depending on which it was at first. And you have to remember what we learned in multiplying complex numbers. You have to FOIL. So you've got to be foiling using the box method in order to keep track of all of the different multiplications that you have to do. And then remembering that I squared is negative 1. So, steps to dividing. You need to divide complex numbers. You're going to multiply by the conjugate on the top and the bottom. You're going to FOIL or use a box method to multiply. Then you're going to simplify the powers of I, mainly that I squared equals negative 1. You're going to do any multiplication, final multiplication, and combining like terms. And then you're going to write your answer in the form of A plus BI. So let's take a look at this one. The first one, divide the complex number. So I have 4 minus 2i divided by 3i. So what I am going to know is that I am not allowed to keep an imaginary number at the bottom of a fraction. That is why we are going to do what we are going to do. And this is called multiplying by the conjugate. And we are going to multiply by negative 3i. On both the top and the bottom. So, when we do that, on the top, okay, we are going to use a box real quick. It's going to be, I'm going to do my work down here, a 1 by 2 box of negative 3i. And on the top, I have 4 minus 2i. So here I get negative 12i. And then for the other multiplication, I'm going to get positive 6, because negative 3 times negative 2 is positive 6, I squared, since I times I is I squared. And that simplifies to be negative 12i. And then remembering that I squared is negative 1. Positive 6 times negative 1 is negative 6. And then divided by, on the bottom, I'm going to get 3 times negative 3 is negative 9. And then I squared. So I still have some simplification to do here. Okay, so that's my raw multiplication. Okay, and then the raw multiplication, I can simplify the top to have negative 6 minus 12i. All over on the bottom. Negative 9, and then the I squared here equals negative 1. So really it's negative 9 times negative 1, or positive 9. And then all three of these numbers here, both negative 6, negative 12, and 9. So both numbers on the top, not just one, but both, and 9 are all divisible by 3. So I can then simplify my answer to negative 2 minus 4i over 3. And that is my divided complex number. Okay, so let's take a look at another example. This example, I have 2 terms on the top and 2 on the bottom. I'm going to completely ignore the top and multiply by 1 minus 3i on the bottom. And 1 minus 3i on the top as well. So the tricky part about dividing complex numbers is that I have to do a box on the top. I'm going to have to do one of these boxes, and I'm going to have to do a box on the bottom to keep track of all of the different multiplications. So on the top, I get 1 minus 2i. On the bottom, I get 1 minus 3i. And then over here, 1 plus 3i, 1 minus 3i. So let's multiply them. 1 times 1 is 1. Negative 2i times 1 is negative 2i. 1 times negative 3i is negative 3i. And negative 3i times negative 2i is 6i squared. And then here, 1 times 1 is 1. 1 times 3i is 3i. 1 times negative 3i is negative 3i. 3i times negative 3 is negative 9i squared. So I'm going to go ahead and write all this out. On the top, I get 1 minus 2i minus another 3i. And then plus 6i squared. On the bottom, I get 1 plus 3i minus 3i minus 9i squared. So I have my top of the fraction, my bottom of the fraction. So I am going to simplify. On the top, 6i squared. This is like saying 6 times negative 1. Again, using the property that negative 1 is equal to I, so I substitute that, which is negative 6. So on the top, really, I have 1 take away 6, or negative 5. On the bottom, and then I can combine the i's as well, excuse me. Negative 2i minus 3i is negative 5i. And the other one, 1 on the bottom, 3i and negative 3i cancel out. And then negative 9i squared is like negative 9 times negative 1, or positive 9. So 1 plus 9 on the bottom gives me 10. So 1 plus 9 on the bottom is going to give me 10, and I'm going to move it to the middle of my fraction. And that's it. That's my answer. It is negative 5 minus 5i over 10. But now I see that negative 5, negative 5i, and 10 can all be divided by 5, so I've got to do that. So I still have to simplify. So my final answer is actually going to be negative 1 minus I over 2, because everything is divisible by 5. And so here is my final answer. Divide the complex numbers again. So another example, this time the numbers on top are a little bigger, but and then one of the real numbers, the real number here is also negative, but the idea is still the same. We're going to multiply by negative 3 plus I. I don't want to take my eraser. Negative 3 plus I. This stays the same. The negative 3 stays the same. I got to be careful to remember that. But it's just the I that changes sign. And we do that for both the top and the bottom. I keep making this curved by accident. So negative 3 plus I. So on the top and the bottom, I'm going to just FOIL it. I'm just going to FOIL it. You can feel free to use a box, but I'm just going to FOIL. So 7 times negative 3 is negative 21. 7 times I is 7i. 4i times negative 3 is negative 12i. And 4i times I is 4i squared. So that's the top. The bottom, negative 3 times negative 3 is positive 9. Negative 3 times I is negative 3i. Negative I times negative 3 is positive 3i. And negative I times I is I squared. Negative I squared. Yep, I wrote a positive. It is negative I squared. Okay. So then final simplification on the top here with this 4i squared. This is like saying 4 times negative 1, which is negative 4. On the bottom, I squared is just equal to negative 1. So that helps me to my simplification of on the top. Negative 21 minus another 4. So negative 21, and then it's plus negative 4. So that's negative 25. And then 7i, take away 12i, is negative 5i. Over the 3 i's here, they cancel each other out. Plus minus. 9, take away I squared. Well, take away I squared is negative 1. So 9 take away negative 1 is 10. And then all of these are reducible. Each and every one of those is divisible by 5. 25, negative 5, and 10 are all divisible by 5. So my final answer is going to be negative 5 minus I over 2. All right, and one more example, guys. I have nothing but a real number on the top, and I have a complex number on the bottom. So again, I'm going to multiply by the conjugate. 1 take away I, and 1 take away I. So on the top, I'm going to get negative 2 plus 2i, because I have a double negative here. And on the bottom, I am going to get 1 plus I minus I, and then minus I squared. So on the top, I get, I'm going to be left with that negative 2 plus 2i. That was nice and easy to multiply out. But on the bottom, these i's are going to cancel. So I get 1 take away I squared. I know that this right here is equal to negative 1. So it's really saying 1 take away negative 1, or 2. So 2 is going to go on the bottom of my fraction here. And then each and every one of these, negative 2, 2, and 2, are all divisible by 2. So I can divide this, this, and this by 2 to get negative 1 plus I over, my fraction bar didn't look the greatest there. Use the eraser to just fix my fraction bar really quick. All over 1. But when I divide by 1, I don't actually have to write that. So my final answer is just negative 1 plus I. So in summary, guys, when we divide complex numbers, we don't actually do any division. Instead, we multiply both the top and the bottom by the conjugate of the denominator. Remember to always FOIL your answers or use a box, and that you should always remember that I squared equals negative 1. Then make sure you multiply correctly, cancel your I terms, and remember to combine any like terms. That's it for dividing complex numbers, guys. Thanks for watching, and I'll see you in the next video.